Okay, students, this video is for you, especially the seniors who weren't able to join us the block before we execute the breast cancer lab. I'm really excited for you guys to have this opportunity. It's definitely something that you can add onto your resume because in addition to having completed a bacterial transformation lab, we will also have now completed doing a gel electrophoresis. So there's a couple of important things that I do need to run through with you guys just to make sure that you feel confident. So I'll direct you to those things in Schoology. So if you open up Schoology and you go to our courses, you will see in the upcoming the BRCA gel electrophoresis lab. This is in the assessments category. So please take it very seriously. But if you do everything you're supposed to do during class time, I have every confidence that this shall only bring your grade up. So I just want to go over the slides template. You'll be working in partners. And so you'll go to the slides template. This is part 2 after you've completed the entire lab next week. You're just going to click make a copy, and only one of the 2 of you in the group need to make that copy. The next most important part is that you click on the share button, and that when you're sharing, you change the permissions to Cathedral Catholic, and you also change the permissions to editor. In addition to typing in your partner's names, you also need to type in my name here to share. So you would type in about 0.25. So you'll put that answer in there. Let me do something in my settings here. I want to change to my AirPods, but I guess my speaker can hear me. So, okay, let's try something else. Okay, so sorry about that. Just a little speaker change because I picked up my phone. Okay, so you're going to then go ahead in the same way, measure all these values right here, and then you're going to calculate the RF values here. So I am going to have you guys hit pause and take this moment to do that in this second right here. Okay, hopefully you've had enough time to go ahead and do those calculations. I'm going to give you a second just to double check as I get my screen ready to share here for you guys. So give me just a second. Okay, so answer here should be 2.3 millimeters. Answer for the 500 base pair fragment should be 3 millimeters. Answer for the fragment here is 3.5 millimeters. And then answer for the 100 is 4.3 millimeters. Calculations here as we come down, same thing, 0.34, 0.44, 0.51, and 0.64. Okay, so you have your RF values. And the next thing we're asked to do is to plot a standard curve, fragment size versus RF on log Y semi-log paper. Most of you, I think, if not all of you, have never made a plot on semi-log paper, which is fine. I'm going to teach you guys how to do that today and the reasons why that we're going to do that. So before we do that, I would like to take our values here. We're going to copy them, and we're going to jump all the way down to the semi-log graph, which you guys should have put that semi-log information here. Okay, so we'll just put it right here just for now. And then we're going to grab the information here because it's asking us literally right here, plotting the RF values on the x-axis and the fragment size on the y-axis. So I'm going to go ahead and grab that fragment length. Sorry, I'm going to hit copy, and this is just easier for me to do right here. Okay. And then paste image. We're going to keep that right here. Okay. So as you're looking here at the semi-log paper, I hope you can very quickly see there is a funniness or a weirdness about this paper, because if you come across the x-axis here, it has a very regular repeating appearance. But if you come across here, it starts from rather large to exponentially smaller. And then we sort of seem to repeat this sequence over again. And what you're looking at, and the reason why we're doing that, is on the x-axis, this is more like a linear scale, and that's what we're plotting our RF values on. But if you look on this y-axis, it's log in nature. And this is why we call it semi-log, because we're plotting a linear versus a logarithmic scale. And you can even see that represented in the data here because our answers are in the hundredths here, whereas our fragment lengths are in the thousands of base pairs here. So these are our frag lengths. Okay, right in here. And then in here is our linear. So I'm going to help you guys a little bit with that scaling here. I hope you're able to follow along. So again, just making sure that our scale is nice and spread out. We're going to have this as 0 0.05, 0 0.1, 0 0.15, 0 0.2, 0 0.25. I hope you guys can see a pattern here. 0 0.35, 0 0.4, 0 0.45, 0 0.5, 0 0.55, 0 0.6, and then finally 0 0.65. So then how do we label going this way? Well, since log, and this is log base 10, we're going to start off at the number 10 here, okay? Which would be, what is 10? If we talk about 10, it's what? 10 to the 1, okay? And as we move up the side here, and you always want to go for the thickest tick mark here. A lot of students will get confused and start adding it, their numbering or their graduations right here. You always need to hit the thickest tick mark. You'll know if you chose the wrong tick mark because when you get to the end part of the repeating pattern, you'll see that you've done it wrong. So if this is our 10, then this is going to be 20, 30, 40, 50, 60, 70, 80, 90, and yep, we picked the right numbers, 100, or we also know that 100 is 10 to the 2, okay? So as we make our way up through this portion right here of the logarithmic paper, we're not going to be counting by tens anymore. We're now moving by 100s. So you guys can probably guess this is going to be 200, 300, 400, 500, 600, 700, 800, 900, and yep, we picked the right one. This should be 1,000 or our 10 to the 3. And if I look at my scaling, I actually only need to go up to 2,000 here. So here, as I move up my scaling here, instead of counting by tens, instead of counting by 100s, I am going to be counting by the thousands. So this big tick mark here is going to be 2,000. And just to kind of go a little extra, because we know from the AP exam, it's always good to kind of like space yourself out. I'm going to come up to 3,000. Okay. So now the idea is you're going to plot a standard curve, okay? And so you're plotting the standard curve. It said you're going to be making your RF value and then plotting it against your base pairs. So let's take a look and see what that is. So we're going to go over 0.25. It might be good for you to do like a super zoom in here. So there's our 0.25. And then we're going to go all the way up to 2,000. So 0.25, let's see if I can keep myself together here and get the right point. Already lost myself, so 0.25 is all the way up here. And I've plotted my first point, so I can check that off. My second point is 0.34 and 1,000. So if I come over here, my 0.34 is here. And I'm going to come all the way up and plot that against 1,000. And then I plotted my second point. And you really should connect your lines as you go. And so I'm not going to plot the rest of this for you. You should be able to do that right now. So I'm going to press pause and let you finish that, and then we can check in our answers. Okay, so hopefully you've been able to plot those points, not too hard, nothing difficult about it. It's just a matter of being able to get your points plotted and using just a new graphing method, not a big deal. I'm going to get a moment here just to get myself situated so you guys can see what the final answer is. So then you have something that looks like this. And this is called a standard curve. Okay, so this is what's called a standard curve. So why are we using a standard curve? I will show you because we're going to come back into the lab. And what you're going to see is when you run the gels, I have blocked out Rachel, Deborah, and Hannah and the negative control here. So you're going to be getting gel fragments here. But I have given you Sarah's information. And so you're going to do that same situation here in table, let's see, say, table 2, where you are measuring fragment 1 and fragment 2, putting the A and the B here. B is just 6.7 all the way down. There's no difference there. And the fragment 1 is always the top fragment. So this would be fragment 1 right here, and this would be fragment 2 right here. So same idea to get the A measurements there. I will go ahead and just give it to you for Sarah, and we should be able to, I'm going to go ahead and do something with you guys. Let's see. Give me 1 second. I haven't done this in a long time. Okay. So the information for Sarah, measuring the same way we did last time, was 2.3 for the first fragment, 2.7 for the second fragment, 6.7 here, and the RF for that is 0.34 and 0.40, calculated in the same way that we did up there. Now, what does this tell you? We don't have the fragment lengths of each of these 2 separate fragments here. When you guys had me as freshmen, what I literally would have done was had you try and line up, align the fragment to the marker, and again, align this fragment to this marker and estimate it. But now that you're sort of in an elevated college level class, we no longer do that. We're going to use the standard curve that we just created to come up with the exact base pairs. So how do we do that? We're going to take these 2 values right here. So we'll copy, and I'll go back to my standard curve, which is right here. And I'm going to paste the information here. So fragment 1 is 0.34. And if I take a look at, if I go over here to 0.34, and it's hard for you guys to see, but you'll get the idea. And I come all the way up here, and then I come across, the value I get for base pairs is 1050. Okay, so you're going to put that back into this chart in here. So that's what I would get here, which would be 1050. And then what I do is this will correspond to an allele present. So I come down here and I see what allele this corresponds to, and that actually corresponds to allele 8. So you should be able to do the same thing with fragment 2, okay? So we're going to use that 0.4. And then we'll come over to our 0.4 here and then draw a line all the way up. And that's going to correspond to about 650. So then we'll put that in here. And then we see what allele that corresponds to. Now, if I'm looking here, I've got 600 and 700. The best thing to do is to round up. So I'm going to round 650 up to 700. And then that corresponds to allele 6. What you guys will be doing is running the gel to get genetic information here and here. You've already plotted your standard curve. You're going to be getting information here and here. And then you're going to be answering our final questions and then determining whether or not Rachel and Deborah and Hannah have certain types of alleles. So please make sure that when you come to class that you have your standard curve done and finished. You've already had time to make sure this is completed. Make sure that you, as I'm coming back up here, that you have questions 1, 2, 3, and 5 answered in complete sentences. And you're also more than welcome to start working on your slides with your partners. Very evidently, there was loads and loads and loads of unit connections in here, and we'll have some fun when we come back to class. I hope you found this video helpful, and I will see you in class.